Ouch.
Bummer, dude. Cone snail toxin. One of the most deadly out there. But why do animals have toxins and how can they affect us?
Here it is. Toxins are poisonous compounds produced by living organisms that act in very low concentrations. They affect the actions of our nervous system. That's pretty important.
Our nervous system tells our body what all the other parts are doing. Its two parts, the central and peripheral systems, are a highly specialized network of nerves called neurons. Now they're interconnected and pass information using electrochemical signals. These signals coordinate most of our actions, including when we feel pain.
So we're still trying to figure out why exactly some animals produce toxins and how they affect us. And it looks like many animals produce toxins, like snakes.
Toxins vary in snakes. Many are hemotoxic, like these cottonmouths and this copperhead here. Now, other snake toxins, like this squirrel snake's, is highly neurotoxic, meaning that it affects the nervous system. The venom of these snakes is full of all sorts of neurotoxins. The combined effect on their prey is to shut down the nervous system.
Check this, even small ants produce toxins.
Okay, this is a bullet ant from Costa Rica. It has a neurotoxic peptide called ponerotoxin, and for a would-be predator like this anteater here, it's extremely painful. It disrupts the nervous system by messing with the sodium channels. But don't worry, it'll only sting if you make them mad, which Hazen is definitely not going to do today.
This is the famous bullet ant. Out of all insects out there, this is the one you definitely do not want to get stung by.
And of course, looks like spiders do too.
This black widow spider injects an interesting toxin. When injected into their prey, it means instant immobility.
And apparently, even snails.
That's right, even snails. In fact, these snails have one of the most toxic venoms in the world. But to find out why these snails have such a powerful toxin, let's visit a cone snail expert.
So cone snails are found all over the Pacific, especially here in Hawaii.
So we're here to see Dr. J.P. Bingham, who's studying cone snail toxins.
But first, let's figure out what might happen to a human that gets injected by cone snail venom.
There has been fatalities reported from cone shells. And what happens, unfortunately, the person picks up one of these beautiful, pretty shells. You would think a snail would actually have the ability to kill you. They hold them, and the snail doesn't like that, and it will inject through defense mechanisms into the hand, and that's been a reported case. So the venom now is circulating into the system. What it's slowly going to do is going to travel through the whole body. As it does, it starts blocking and closing down ion channels. Ideally, the first part of response is going to be attacking the diaphragm, where the lungs, to move the air in and out of the lungs. That usually happens first off, so respiratory suppression or breathing stops. Other parts, including the heart will stop contracting. The first thing they feel is numbness. So basically the toxins are designed to switch off the nervous system very efficiently and quickly.
But one thing we learned is that even though these toxins can be extremely deadly, they can also be very beneficial to us.
Some of the compounds present in the cone shells have seen their uses in pharmaceuticals. At the moment, there is a cone shell toxin that's 1,000 times more potent than morphine, has no addiction or tolerance. So in other words, a toxin can become a good drug, and that's being used throughout the world at the moment.
But to really understand why a snail might have a toxin like this, we must understand exactly how it uses its venom.
Cone shell being a snail, you wouldn't think it would be that nasty, but it is. It has toxins to subdue its prey. It wants to kill its prey quickly and effectively. In a marine environment, there's a lot of predators and scavengers. So once this cone shell preys on its prey, it wants to ensure that it's immobilized it, because once the cone shell's tethered to its prey or injected its prey, it's defenseless.
Okay, let's review this quickly. Our cone snail is a sit-and-wait predator. To capture its prey, it has a series of tethered harpoons loaded with potent venom. When a prey, like say this fish, swims by, it has to immobilize the animal as fast as possible, and that's where the deadly toxins come into play. But how do cone snail toxins work, and do they all work the same way?
We have toxins from cone shells that hit sodium channels, calcium channels, NMDA receptors, potassium channels, acetylcholine receptors. They hit a whole menagerie of these transmitting or ion channels or receptors. The idea is the snail wants to immobilize it, inhibit, destroy the activity of these ion channels. Once you destroy the activity or fluctuation of ions in the system, you destroy the nervous system. The nervous system becomes dead, and that is what the snails want to do. They want to immobilize their prey quickly, and they use these toxins to do that job.
Because each toxin could have tremendous medicinal benefits, Dr. Bingham's goal is to isolate new compounds. To do that, he first farms snails. To get their venom, he must milk them. It's a dangerous job for sure. He entices the snails to feed, and then switches the fish for a small membrane-covered vial. After the snail launches the harpoon, he must sever the tether, and then feed it a fish for reward. From there, he runs the samples in a high-pressure liquid chromatographic instrument. The only problem is that there are lots and lots of compounds to be found.
So what we're learning is that cone snails have lots of different toxins, and we know very little about them. Who knows, maybe someday you'll discover an unknown compound new to science.
Like I did.
Like you did. You discovered a lot of new ones.
Never stop exploring your world.
Yo, boy, this is the bullet ant. It's like the worst in the insect world, yo. It's got a sting up the house. Who's the cone guy?